This topic is about being able to solve problems involving sigma notation. So what is sigma? So sigma is a Greek letter. So you write it like this. Okay, and it means the sum of. Okay, e.g., so if we have something like this, sum of r equals 1 to n of ur, all that means is r equals 1 is the first value to substitute into expression. So this is sum of ur, which is either ur or it's going to be an expression there. And this is the last value to substitute into expression. So if 1 is the first thing you substitute in here, so you replace r with 1, then you get u1. Sum means add, so add. What's the next number after r equals 1? Is r equals 2. So then you substitute 2 into this expression. It is ur, you get u2. You substitute 3 next, then 4 next, all the way up to un. So the terms in the series, is a series because we're adding all these things together, are obtained by substituting the values 1, 2, all the way up to n. In turn, for r in ur, for this example only. So obviously depending on what your expression is, it will change. So let's look at a few examples. So here we have sum of ak, where k equals 1 to k equals 6. So first thing we need to do is replace k with 1, so we get a1. Then replace k with 2, so we get a2. Then replace k with 3, 4, 5, all the way up to the last number, which is 6. So that would be and the series that we obtain from that sigma notation. Okay, so if I look at the second one, okay, k is equal to 5. So we start from 5. So substitute 5 in first. So it's a5. The next number after 5 is 6. So a6. So we need to keep doing this until all the way up to 8. Plus a7 plus a8. And that would be. So the top number and the bottom number are very important because they tell you what to substitute in first and what to substitute all the way up to. Okay, this one says k equals 0 all the way up to n. So the first number we substitute in for k is 0. And the next number would be a1 plus a2 all the way, because we don't know what n is, all the way up to an. So we don't know how many terms there are in this series. But we do know there is actually n plus 1 terms, but not as a number. Okay, next one, we're starting from k equals 1. So if I substitute 1 into this expression, then I get f of a1. All the way up to 5 I need to go, so f of a2 plus f of a3 plus f of a4 plus f of a5, which is the last term. That's it. Okay, so sometimes you're asked to calculate values. So let's look at this example. So that means we're starting from r equals 1. We go all the way up to 4. So we're substituting in these values into this expression, which is 3r minus 1. So that means the first term will be 3 times 1, take away 1. The second term will be 3 times 2, take away 1. The third term will be 3 times 3, take away 1. And the last term will be 3 times 4, because the number on the top is 4. So 3 times 4, take away 1. So when I simplify each term, my series, I get 3 take away 1, which is 2, plus 6 take away 1 is 5, plus 3 times 3 take away 1 is 8, plus 3 times 4 take away 1 is 11. So when I add this together, I get 7 plus 8, 15 plus 11, 26. 26 will be my final answer for that one. If I look at this example, next example, so my starting number that I substitute in for r is 3, the last number is 8, and my expression is r squared. So the first term is 3 squared, plus 4 squared, plus 5 squared, plus 6 squared, plus 7 squared, plus 8 squared. Now I'm going to work this out. In my head, I'm just going to use a calculator. When I put this into my calculator, I get 199. Again, let's look at the next term. Next segment calculation that we need to do. So we're starting at k equals 3, ending at k equals 5. So that means we're going to get only 3, 4, 5, which is 3 terms. And that's the expression that we need to substitute into. So the first term will be 3 times 3 plus 2 to the power of 3. So all we're doing is replacing k with 3. Then we substitute in 4 now for k. So 3 times 4 plus 2 to the power of 4 plus 3 times 5 plus 2 plus 2 to the power of 5. That means I get 9 plus 2, which is 11 to the power of 3, plus 14 to the power of 4, plus 17 to the power of 5. If I put that into my calculator, I get 1,459,604. Okay, write out the following sums and evaluate them. Okay, so now I equals 1 to 4, so substituting from 1 all the way up to 4 into 2 to the power of I. So I get 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4, which is just 2 plus 4 plus 8 plus 16, which is equal to 30. Okay, next one, 2 to the power of m plus 3, where m starts from minus 2 to 1. So let's substitute in. First one will be 2 to the power of minus 2 plus 3, plus 2 to the power of next number up is minus 1 plus 3, plus 2 to the power of 0 plus 3, plus 2 to the power of 1 plus 3. And that's the last number we substitute in, 1. Okay, which gives me 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4, which is what I've calculated already in the previous question. So it's going to give me the same answer, which is 30. Okay, let's look at the next one. So starting from x equals 1 all the way up to 4, and that is my expression. So my first term will be minus 1 to the power of 1 times 1 to the power of 3. Next one will be 2, so substituting 2 in, minus 1 to the power of 2 times 2 to the power of 3, plus minus 1 to the power of 3 times 3 to the power of 3, plus minus 1 to the power of 4 times 4 to the power of 3. Okay, negative 1 times 1 cubed gives me minus 1. Minus 1 squared is positive 1 times 2 cubed is 8. Minus 1 cubed is minus 1 times by 3 cubed is negative 27. And the last one will give me a positive 64. So when I put that all into a calculator, I end up getting 72 take away 28, which is equal to 44. The last one I need to do, okay, substituting from 0 to 3 into this expression. So first one would be 0 times 0 plus 1 plus 1 times 1 plus 1 plus 2 times 2 plus 1 plus 3 times 3 plus 1, which gives me 0 plus 1 times 1 plus 1 is 1 times 2, so it's 2 2 times 3, which is 6, and 3 times 4, which is 12. So altogether, when we add it together, we get 20. So evaluate the following arithmetic sequence. So arithmetic series. Okay, let's move it around a bit. So let's just go for A here. So sum R equals 1 to 23 of R is the same thing as 1 plus 2 plus 3 plus blah 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 all the way up to 23. So in this case, because we're trying to find the sum of arithmetic, we know this is arithmetic series because there's a common, A is equal to 1, the common difference is equal to 1. We know n is the number of terms is 23, and we even know the last term, which is 23. So we can use either Sn equals n over 2 times 2a plus n minus 1 times d, or Sn is equal to n over 2 times a plus l. In this case, it's easier to use Sn is equal to n over 2 times a plus l. So that means S of 23 is equal to 23 over 2 times 1 plus 24. Sorry, 1 plus 23. Which is the same thing as 24 divided by 2 is 12. So it's 23 times 12, which is equal to 276. Okay, let's look at B. So this only works because it's an arithmetic series. So sometimes they might not tell you it's an arithmetic series. If when you write out the numbers, you notice that it's an arithmetic series, then use Sn formula. So sum R equals 1 to 32 of R take away 3. So substitute 1 in first. 1 take away 3 is minus 2. And then 2 take away 3 is minus 1. Whoops, no commas in the middle. It should be a plus in the middle because it's a summation. And then if you substitute 3 take away 3 is 0, all the way up to 32 take away 3, which is 32 take away 3, which is 29. Okay, so here we know it's an arithmetic series because A is equal to minus 2. Your difference is, common difference is 1. You know N is equal to 32 values. And you even know L is equal to 29. So you can use either version. So I'm going to use, just to show you, obviously there's two different ways. Let's use the first formula for Sn, which is 2a plus n minus 1 times g. So we're trying to work out S of 32, which is equal to 32 over 2 times 2 times minus 2 plus 32 take away 1 times the common difference, which is 1. Okay, which is the same thing as 32 divided by 2 gives me 16. I get 31 take away 4, which is 27. So 16 times 27, which is equal to 432. So that would be the answer for part B. Okay, if I'm doing part C now, I'm doing sum of R equals 7 to 13 of 3R minus 2. So 3 times 7 is 21, take away 2 is 19. 3 times 8 is 24, take away 2 is 22. All the way up to 13. So 3 times 13 is 39, take away 2 is 37. Okay, so in this, again, we can see that we're adding 3 in each case. So the A is 19. The common difference is 3. What we do need to find out is n. Now it's easy to find out n because we're counting from 7 to 13. So n is going to be 13, take away not 7 but 6 because we want to include 7. So 13 take away 6, which is equal to 7. So n is equal to 7, and the last term is 37. So if I want to use the second formula for Sn, so Sn is equal to n over 2 times a plus l. Then it's the same thing as working out S of 7, which is 7 over 2 times a, which is 19, plus l, which is 37. Okay, which is equal to 7 over 2. 37 plus 19 is 56. Okay, if I divide by 2, so 7 over 2 times 56 will give me a value of 196. Okay, Now we're going to go backwards. So if we write the following series in sigma notation. Okay, so A. So we've got A is 7, and we've got, there is a series because, sorry, it is an arithmetic series because we're adding on 5 each time. So the common difference is 5. And we've got 1, 2, 3, 4, 5, 6 terms. N equals 6. So if you want to find out, un will be a plus n minus 1 times d. Then un will be equal to 7 plus 6 minus 1 times d, which means un will be equal to 7 plus 5d. So if you want to write it out as sigma notation, so that means, made a mistake here. So what we need to find is a expression in terms of n for un. So it's the same thing as un is equal to a, which is 7, plus n minus 1, we don't know what n is, times 5, which is equal to un is equal to 7 plus 5n take away 5, which means un is equal to 5n plus 2. So that is the expression to find the nth term. So if I want to write it as a summation of r equals, the expression will be 5r plus 2. It can be 5n plus 2 if you want, it doesn't matter. And the first number we substitute in is 1. And because we want 6 values, obviously then r must go up to 6. And let's check that it works. If I get 5 times 1 plus 2, I get 7. 5 times 2 plus 2 is 12. All the way up to 5 times 6 plus 2, which is 32. So that does work. So it's correct. Okay. So the final answer is this one as an expression. Okay, B. Let's look at the next one. So it's 3 plus 6 plus 9 plus all the way up to 99. Then I know this is 3 times 1, this is 3 times 2, this is 3 times 3, and this is 3 times 33. So if I want to write it as an expression, this is the un is equal to 3 times n. So that means if I were to write it as a summation, it was sum of 3n, where n starts from 1 and goes up to 33. So let's check when we substitute in, what do we get? 3 times 1 is 3, plus 3 times 2, which is 6, plus 3 times 3, which is 9, all the way up to 3 times 33, which is 99, which is correct. Okay, let's look at the next one, which is C. Okay, so it's 1 plus a third plus a ninth plus 1 over 27. That is the same thing as 1 over 1 plus 1 over, so 1 over 1, which is 3 to the power of 0, plus 1 over 3 to the power of 1, plus 1 over 3 to the power of 2, plus 1 over 3 to the power of 3. So I can write it as a summation as sum of 1 over 3 to the power of, now if you look at this is the first term, but we've got 1 less power of 0, we raise it to 3 to the power of 1 less, so it's going to be n minus 1, because we want the first number to be 0, so that n going from 1 all the way up to 4. So let's see what happens when you substitute in. You get 1 over 3 to the power of 1 minus 1, which is 0, 3 to the power of 0, which is just 1, so you get 1 over 1, plus 1 over 3 to the power of 2 minus 1, which is 1 over 3, plus 1 over 3 to the power of 3 minus 1, which is 1 over 3 squared, which is 1 over 9, and last one will be 1 over 3 to the power of 4 minus 1, which is 1 over 3 cubed, which is 1 over 27. So that does work out. So that one would be my answer. There's lots of different ways of expressing it, by the way. That is not unique. That's one of the answers you can get. Let's do D here. So I've got 3 plus 6 plus 12 plus 24. What I realize is we're timesing by 2 to get the next one. Okay, so I can write it as 3 times 2 to the power of 0, plus 3 times 2 to the power of 1 plus 3 times 2 to the power of 2 plus 3 times 2 to the power of 3. So I do get those numbers in that series. They're all equal. So if I want to write it as a summation or a sigma notation, so it's 3 times 2 to the power of n minus 1. N going from 1 to, I've got 4 terms, so n equals 1 to 4. Now this is the same thing, just so I can show it differently. Same thing as writing 3 times 2 to the power of n, where n goes from 0 to 3. Because then I get 3 times 2 to the power of 0, which is the same thing as the first term. And the last term will be 3 times 2 to the power of 3, which is the last term. So it's the same thing. So if you adjust the expression, you have to adjust your upper and lower limit on your summation. So you can have this as an answer or this as an answer. Okay, E. Okay, so we've got minus 4 plus minus 1. I'm going to put brackets around it so you can see. 2 plus 5 plus 8 plus all the way up to 17. So I know this is an arithmetic series. It's increasing by 3, so un will be equal to 3n. But the first term is minus 4, so I need to take away 7. So 3n take away 7. What I need to do also, don't have enough space here, so I might as well write it here. So E is un is equal to 3n minus 7. So A is equal to minus 4 in this case, and the D is equal to 3. We don't need that information actually, but we need to find out what term what is n equal to. Well, how many terms do we have there? So if we equate the nth term to 17, then that means 3n will be equal to 24, which means n is equal to 8. So that means we have 8 terms here. So that means my summation will be 3n take away 7 for n going from 1 all the way up to 8. So let's see if we get the same series when we do that. So 3 times 1 take away 7 gives me minus 4, plus 3 times 2 take away 7 gives me minus 1, all the way up to 3 times 8 take away 7 is 24 take away 7, which is equal to 17. So that's going to be the right thing. So that is the correct answer. Okay, next question. So show that question. So show that sum of r equals 1 to n of 2r is equal to n plus n squared. So sum of r equals 1 to n of 2r is equal to first 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 all the way up to 2 times n, which is the same thing as 2 plus 4 plus 6 plus 8 plus ... 2n. So in this case, you have a is equal to 2. Your common difference is equal to 2. The last term is 2n. And the number of term is 1 to n, so it's just going to be n is equal to n. So for Sn, because you're trying to work out the summation of these things, it is an arithmetic series, so you can use the Sn formula. Sn will be equal to n over 2. Because we have the last term, I'd use the a plus l version of it, which means it's going to be n over 2. A is 2, and the last term is 2n. And now you can divide everything inside the bracket by 2 and get rid of the 2 here. So you get n times 1 plus n, which is the same thing as n plus n squared when you expand the bracket, which is what we wanted. Okay, next question. Show that sum of r equals 1 to n of 2r minus sum of r equals 1 to n of 2r minus 1 is equal to n. Okay, so sum of r equals 1 to n of 2r is equal to 2 times 1 plus 2 times 2 plus 2 times 3 plus dot 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 plus 2 times n, which is equal to 2 plus 4 plus 6 plus 2n. So in this case, a is equal to 2, d is equal to 2, n is equal to n, and L is equal to 2n. So again, this will be the same thing as working out S of n, which is equal to n over 2 times A plus L, which is equal to n over 2 times 2 plus 2n, which is n times 1 plus n, which is equal to n plus n squared. Now, I know I've done this in the previous question, but because it's a different question, just want to show it again. Okay, so same thing I need to do is sum of r equals 1 to n of 2r minus 1, which will be 2 times, the first term will be 2 times 1, take away 1. Second term will be 2 times 2, take away 1, plus 2 times 3, take away 1, plus all the way up to 2 times n, take away 1, which is equal to 2 take away 1 is 1, plus 3, plus 5, plus all the way up to 2n, take away 1. Now we know in this case a will be, it's an arithmetic series because it's increasing by the same amount. So a is equal to 1, d is equal to 2, n is equal to n, and L is equal to 2n minus 1. So it's the same thing as working out Sn, which is equal to n over 2 times A plus L, which is equal to n over 2 times 1 plus 2n minus 1, which is equal to n over 2 times 2n, which is just n squared. So when I'm doing sum of r equals 1 to n of 2r, take away sum of r equals 1 to n of 2r minus 1, the same thing as n plus n squared, take away n squared. So I'm just left with n, which was what I was trying to prove. Find in terms of k these two values. So a and b. Let's work out a. So sum equals r equals 1. R equals 1 to k of 100 minus 2r is equal to 100 minus 2 times 1 is 98. 100 minus 2 times 2 is 96. All the way up to 100 minus 2k. So what we do know is this is an arithmetic series. So a is equal to 98. Your L is equal to 100 minus 2k. Your D is equal to negative 2. And your N is equal to k. Because if you're counting from 1 to k, you've got k terms. Okay, so it's the same thing as working out S of k, which is equal to k over 2 times A plus L, which is equal to k over 2. A is 98 and L is 100 minus 2k, which is equal to k over 2 times 198 minus 2k. So if you divide by 2, everything inside the bracket, you get rid of the over 2 at the front, at the beginning. So that means you get 99 minus k. If you expand the bracket, you get 99k minus k squared as an expression for the summation. Okay, B, let's go through B now. So sum of r equals 10 to k of 7 minus 2r. So 7 minus 2 times 10 is 7 minus 20, which gives me minus 13. If I do 7 minus 2 times 11 is 7 minus 22, which gives me minus 15. 7 minus 2 times 12 is 7 minus 24, which will give me minus 17, all the way up to when I substitute k in, which is 7 minus 2 lots of k. Now what we do know is, obviously this is an arithmetic series again, so a is equal to minus 13, d is equal to minus 2, L is equal to 7 minus 2k. Now n is where you might have an issue. And how many number of terms do we have? Because we're doing k, going from 10 to k, it'll be k take away 9 terms, because we want to include the 10th when we substitute 10 in, so it's going to be k take away 9. Okay, so the same thing as working out s of k take away 9, which is equal to, remember, n over 2 times a plus l. So it's going to be k minus 9 over 2 times a, which is negative 13, plus l, which is 7 minus 2k, which is the same thing as k minus 9 over 2 minus 13 plus 7 is minus 6, take away 2k. We divide the inside of the bracket by 2, you end up with k minus 9 times minus 3 minus k. If you expand this bracket, you get 27, positive 27, plus 9k minus 3k gives me plus 6k, and then I get minus k squared. Okay, last question. Given that sum of k equals, so sum of r equals 1 to k, 8 plus 3r is equal to 377. Show that 3k plus 58 times k minus 13 is equal to 0. Okay, so sum of r equals 1 to k of 8 plus 3r is the same thing as substituting first 1 in, so 8 plus 3 times 1, which is 11, plus 8 plus 3 times 2, which is equal to 8 plus 6, which is 14, plus all the way up to 8 plus 3k. Okay, so here, a is equal to, I know it's an arithmetic again series because it's increasing by 3 each time. So a is equal to 11, d is equal to 3, l is equal to 8 plus 3k, and n is equal to k. So it's the same thing as working s of k, which is equal to k over 2 times a plus l, which is equal to k over 2 times 11 plus 8 plus 3k, which is equal to k over 2 times 19 plus 3k. Can't divide inside the bracket by 2, so what I do know is this must be equal to 377. So therefore, k over 2 times 19 plus 3k must be equal to 377. So if I times by 2, I get k times 19 plus 3k is equal to 754. If I expand the bracket, I get 3k squared plus 19k. If I move also the 754 to the other side, I get negative 754 is equal to 0. Now I know this can be factorized to 3k and k. All I need to check is that 15 times minus 13 does give me minus 754, and the middle terms do cancel, do expand to give me 19k, which it does. So 58 and take away 13 here. So that is it. Part B says, hence find the value of k. So k is equal to either negative 58 over 3 or k is equal to 13. As k has to be great, because k is at the top, it has to be greater than 1, greater than 0. As k is greater than 1, k must be equal to 13, because the other one's negative.